Good morning, good afternoon, good evening, AP Biology. My name is Chris Mansour, and I'm an AP Biology teacher from Tiffin, Ohio, and I teach high school biology at Tiffin Columbian High School. And I'd like to welcome you to topic 3.4, cellular energy. This is daily video 1, and this lesson will describe the role of energy in living organisms like yourself. And we're going to focus on a skill today, and that skill will be on how to provide reasoning to justify a claim. Justifying a claim is a very important skill you need to have to be successful in the AP Bio exam in May. And so what will we learn? Always a good question. We need to have some kind of objective. So what will we learn? What do living things use chemical energy for? So maybe pause the video here and jot down some ideas, but think about as you're sitting here, what are you using chemical energy for? Is it to try to pay attention? Is it to write down some notes, right? And how is energy efficiently transferred in a biological pathway? Efficiently is the key. We want to be able to conserve and we want to be able to be efficient as possible because as you're going to find out, we do waste a lot of energy. So all living systems require a constant input of energy, and sunlight is that main energy input for a living system. As you can see from that diagram, that light energy from the sun is going to be hitting that chloroplast of that autotroph. And as we hopefully know, autotrophs capture energy from physical sources like sunlight or chemical sources and transform that energy into an energy source usable by all cells. It would be nice if we could just go out in the sun and photosynthesize. It doesn't work that way. And so we do need sunlight for autotrophs. But during every energy transformation process, some energy is unusable and often lost as heat. And so as I said, as we're sitting here now, we are giving off unusable energy in the form of heat. So when we're thinking of energy, we have to understand that life requires a highly ordered system. And highly ordered is important, and it does not violate the second law of thermodynamics. There are two of them, but we're only going to focus on the second law of thermodynamics. Every energy transfer increases the disorder of the universe. I like to think of this as some Dixie cups stacked up. I knock them over with my hand, and I've just created disorder. Living cells are not at equilibrium. If you think of equilibrium, you're thinking of like biological balance. There's a constant flow of materials in and out of the cell. Think of it like when you eat. You're taking food in, waste is coming out, but there has to be a constant flow of materials for you to survive. Same idea, living cells are not at equilibrium. They're taking in materials in, and they're releasing materials. And cells manage energy resources by energy coupling. So energy coupling, that's where an energy releasing process drives an energy storing process. So energy is released, and that drives an energy storing process. And also when we talk about energy, we need to talk about pathways because pathways is how energy is transferred. So pathways in biological systems are sequential. Within a chemical pathway, like I have here in blue, the product of one reaction can serve as a reactant in a subsequent reaction. The sequential reactions allow for more controlled and efficient transfer of energy. So we've got a starting molecule A, those are your reactants. We have linking reaction B to products B. So there's one step in that biological pathway. The products of B will eventually become the reactants for linking reaction 2 to make product C. Then product C will become the reactants for reaction 3 to make product D. The big idea here is that what you start out with A, those reactants are going to be much different than those products at D. But by doing this in a series of small steps, it allows for more controlled and efficient transfer of energy. So let's do some practice. Practice makes perfect. You guys are getting ready for that exam in May. I know it's September here right now. Your teachers are working hard, but we're going to focus on argumentation. Provide reasoning to justify a claim by connecting evidence to biological theories. That's important, is this reasoning part. So skill, practice, argumentation again. A researcher claims that the incorporation of carbon dioxide into organic molecules during photosynthesis does not violate the second law of thermodynamics. Which of the following statements best, key point, best helps justify the researcher's claim? I'm not going to read all those options to you. I'm going to pause the video so that you can maybe talk amongst your classmates, maybe in a Zoom chat, whoever is with you at home. So go ahead, pause the video, and I'll be back here in a second to get your answers. Okay, and we're back. Okay, Sue, who has letter A? Any A's? I'm in here by myself, my classroom. B, okay. C, couple of you. D, the D's have it, so good job. Give yourself a little pat on the back or whatnot. The total system that includes photosynthetic organisms and the sun becomes less ordered over time. The key is less ordered, tying that back in to the fact that the researcher was looking for something that does not violate the second law of thermodynamics. So what should we take away today? Key takeaways: 1, living things like yourself use chemical energy stored in molecular bonds of macromolecules like carbohydrates and ATP to perform necessary life functions. 2, pathways in biological systems are sequential. That's the key, going back a couple slides to that pathway, to allow for a more controlled and efficient transfer of energy. So again, I want to thank you. I know you're working hard. I know your AP teachers are working hard, and I appreciate the time you spent with me. So again, my name is Chris Monsoor. I'm signing off from room 102.